All right, you've made an image with data you've collected yourself with Skynet. It has multiple layers. It has red, green, and blue layers. It has a luminance layer. You've put those together into an LRGB combination. It's really good for the stellar content in your image, seeing the stars, the stellar colors. You've added in some narrowband layers like H alpha and maybe O3 and S2 if you got good enough data. And those narrowband layers, they're showing not stars, but gas, hot gas that's been heated by these very same stars to temperatures of tens of thousands of degrees Kelvin. But there's more going on in your image. Here we see stars, we see star-heated gas, but there's also dust. These dark regions, they're dark because dust is mixed in with the gas, and it's dense enough that it's blocking any light from behind it. Now, there are two things that we want to pull out of these regions. We want to pull out dust-hidden stars. There are stars in there. We can't see them because the dust is blocking at visible wavelengths. But if we go just a little bit redder than the human eye can see, into the near infrared, dust doesn't block light as strongly, and we can see some of the stars that are hidden in these regions. So that's one thing that we're going to learn how to grab off the internet. Near infrared to see dust-hidden stars, and then going out into the mid-infrared, even farther from the visible band, we can see the dust glowing. Just as the gas is heated by these stars, that dust is also being heated by these stars to lower temperatures, hundreds of Kelvin, but it glows in the mid-infrared. So in this video, I'm going to show you how to get infrared data, near infrared and mid-infrared data from something called the Skyview Virtual Observatory. There'll be another video where I show you how to get even better mid-infrared data from a NASA spacecraft called Spitzer, and then yet another video where I show you how to incorporate these new layers into your image. Okay, but this video, Skyview, not Skynet, that's the telescope network, Skyview. And so you can Google Skyview Virtual Observatory. It would take you to this page or a page like it, and you want to select query form, and that would take you here. So this is the query form. And there's all sorts of great stuff here. We're just going to use a little bit of it today, a little bit in the mid-infrared and the near-infrared, but there's other stuff here that we may use at other points in this course. So here's gamma ray surveys. Here we have X-ray fields. Moving down here, we see the ultraviolet, and then some optical surveys like the digitized sky survey is here. IRAS is an older infrared mission. We'll use that in combination with some of our radio maps later on. Here we have TUMAS. TUMAS is that near infrared data set that I was talking about. It was collected from the ground. You know, in the optical, we have U, B, V, R, and I as our kind of standard filters. If you go beyond that, you have J, H, and K, and you see that here, J, H, and K, running from about 1 micron in wavelength to 2 microns. This is a ground-based survey, a telescope in the south. Actually, it's right next to the Prompt telescopes in Chile, like 20 feet away. And then a similar telescope in the north, 1.3 meter diameter telescope. Telescopes observe the southern and northern skies, and that data is all here. And we're going to be using the K band. That's far enough into the near infrared. We still are seeing stellar content, but the dust really isn't an issue. So we can see those dust-hidden stars. Continuing on, we have more infrared. Here we have the WISE survey. This is a NASA mission, observe the whole sky from space in the infrared. And you can see the wavelengths here. I said J, H, and K are 1 to 2 microns. Here you see 3.4, 4.6, 12, and 22. And by the time you get out to 12 and 22, that's where you're not really seeing stars anymore, but you're seeing dust. The dust is glowing at these wavelengths. And then continues on, more infrared and radio. Okay. We're going to start by grabbing the WISE 12. Okay, so you can click on that. But there are a couple of things we have to fill in. First and foremost, the coordinates of our field. So the best way to do that is go to your image. You may have it zoomed in or something. Come down here to the zoom to fit button that will center it up. And then come over here to the zoom in. Don't use your mouse to zoom in. Use the button because this will let you zoom into the very center. And that's what we want. We want the central coordinates. So once you've zoomed in, you can move your mouse around. The coordinates are down here. And you don't need the decimal points, but write down that right ascension, write down that declination, and then come over here and fill it in. And I already have. For my target, your target will have its own unique center. You can also look things up by the name of the target, but if you put in your central coordinates, this would be centered on your image. Okay. Again, we've selected WISE 12. So the only things that are left to fill in are the image size, both in pixels and in degrees. And so you're going to want the same image size. Actually, you want a little bit bigger than your image size. So let's go back to Afterglow here. I'll zoom to fit again. I'm going to grab from Skyview images that are just a little bit bigger than mine. And then we'll crop and trim them once we get them in Afterglow. So to know the sizes, come over here to the second tab, the File Info tab, and you have to select one of the layers. The first thing here you see is the size of your image in pixels, and the second thing is in arc minutes. Let's start with the pixels here. Your image probably isn't perfectly square. Take the larger number. Mine's 1758. So I'll bring up a calculator here, 1758, and then we just want to go about 10% bigger. So multiply by 1.1. So 1934. I think you have to round it off to an integer. And that's what I've put here for the number of pixels that I want. And then you have to specify the size of the piece of the sky that you want in degrees. So again, come back to the File Info. Under the second one, Field of View, here it is in arc minutes. Mine's 12.2 by 12.9. Again, take the bigger one, and it's in arc minutes. And the Skyview form wants it in degrees, so we have to divide by 60, and then again, multiply by 1.1 to get that 10% buffer. So 0.2365 for mine, you'll have your own. And I've already typed that in here, 0.2365. So that's all you need. You need the central coordinates, the survey, and the size in pixels and degrees, and you submit the request. And it will take a second. There it is. It's this big thing. And you may notice there may be some dark spots. These are, I call them tears in the image, but really this is just a place that was so bright it's saturated. And we'll have to treat this once we get it into Afterglow. But anyway, it loads it up, and you want to download the FITS image. So I just press the button, and it's currently downloading that image. While it's doing that, I'm going to come back here, and I'm going to change from WISE 12 to WISE 22. WISE 12 is like warmer dusk, maybe about 300 Kelvin. WISE 22 is cooler dusk, maybe about 100 Kelvin. I'm going to switch to WISE 22. Don't have to change anything else, just submit the request. Give it a second to load. There it is. And this will be a little bit blurrier. You'll see it once we get it into Afterglow, but download it. Come back here. It's blurrier because the longer the wavelength, the blurrier the image for the same size telescope. You may remember when we calculated this for single dish radio telescopes, they have very big wavelengths, and so they're very blurry. Here we're not quite to the radio yet, but we're getting closer. And so the farther we go, the blurrier the image for the same size telescope. Anyway, the last thing we want is 2 mass here. But if you switch from one survey to another, you have to come up here and clear survey selections. It also won't work. So clear it out so nothing's highlighted over here. And we're going to grab the 2-mass K-band now and submit the request. And here you see it's stars. So shorter wavelength, we're back to stellar content instead of emitting dust. But some of these are dust hidden stars. And we want this, and so we're going to download that as well. Okay. It's downloading. And once all 3 of your images have downloaded, you come back here to Afterglow, open files. Under files, you have your workspace. Get in your workspace, upload. And here are the 3 images I just downloaded from Skyview. They should all start SKV. You'll grab these 3 and upload them. Now, I've already uploaded these images, so I'm going to cancel. But you upload them all the way. You can search on SKV. So I've already collected these 3. Here they are. And so you select them and open them. Okay. And here they are. Let's load in all 3 of them. Now go back to your group here and come over to the gear and make sure sync orientations is on. Sync orientations in Sky. Don't sync the display settings. You work very hard to adjust all the display settings to give you your perfect image. Don't sync those, but sync the orientations. Come back here. And that way, when I hop from the picture I've made to these that I just uploaded, they'll be framed the same. So this is the higher resolution. This is the Weiss 12. If you want, you can rename it. Let's call this M16.Weiss12.fits. This one right here is the Weiss 22. I'll rename it. Calling it M16 because that's what this is. That's Messier 16. Weiss 22.fits. So what we're looking at here, this is dust in these cloudy regions. It's emitting as it's warmed up. Here's slightly cooler dust, a little bit blurrier. And then finally here are those stars. I'll rename this M16.2-mass K. That's the 2-micron band dot fits. Okay. Now, in a separate video, I'm going to show you how to align and crop and fold them into your image. But the last thing I'm going to show you in this video is fixing tears. And there's usually no problem in the 2-mass image. That looks fine. In the Weiss image, you might have a tear. We saw those black spots, and here they are. Just a hole in the image. And we need to fill that hole because when we align it to our previous images and crop, it will crop right at the boundary of the hole, and it will crop your optical image as well. So if you had a hole in the kind of the middle of your Weiss image and you align it and crop it with the optical images, it could crop out a lot of your optical image. You don't want that. Check your Weiss 22 as well, but I don't see any tears in it, at least for this particular case, but I do have a tear in my Weiss 12. So to fill this, it's pretty easy. Click on the image, come over here to Pixel Ops, and we're going to go to Advanced, and there's a command. It's img.filled, parenthesis, img.max, parenthesis, unparenthesis, unparenthesis. Here, I'll show it. Here, it's this top one. Basically, anything that is a hole in the image, it will fill it with the max value. We'll use this bottom one in the next video, but this top one here will fill, there's a hole in this image because it was too bright. And so we want to fill it with the max value. You want overwrite files to be highlighted, and it will overwrite it into the same file. Now I'll submit this. And you see it just filled in. It's good to go. Okay. WISE 12, WISE 22, and 2 mass. Okay. That's it for this video.